All right, so with our solving by factoring, finding multiplicity, we're also going to look at marketing application that involves factoring also and using factors. So here we have a design of a box specifies that its length is 4 inches greater than its width. The height is 1 inch less than the width. The volume of the box is 12 cubic inches. So they want to know what's the width of the box. So first of all, so we're dealing with volume. What does volume equal if we're talking about a box? Okay. Length times width times height. Now this one specifically says that the length is 4 inches greater than the width. So let's call this the width here, this side of my box. I'll give you a chance to draw that box if you want. As you can see, I'm not a great box drawer. So if the width is W, what would be, how do I represent the length then? It's 4 inches longer, right? 4W would be 4 times longer. So we got the length would be W plus 4. And it says the height is 1 inch less than the width. So that would be W minus 1. And to find volume, we multiply length times width times height. They tell us in this case that the volume is 12, and so that's equal to W times W plus 4 times W minus 1. So we're going to do a little bit of multiplication here then to find the product of the length times width times height. So we got to do our, we've had some good practice with this. So if we FOIL these two together, we'll get W squared plus 3W minus 4. And then we get W cubed plus 3W squared minus 4W equals 12. So it looks like this we might be able to factor by grouping them to help us find the answer. So if we move the 12 over to the other side, we get 0 equals W cubed plus 3W squared minus 4W minus 12. So we factor by grouping. We have W plus 3, and then W plus 2, and W minus 2, right? Because we've got W squared minus 4. So then this tells me that W could be -3, -2, or 2. Are all those answers possible for the width of this box? All right. Can't have a negative width, so the width then would be 2 inches. So here's a problem where they're talking about the volume of a box. So I have to use my formula for volume, what I know about the volume of a box. Plug in the information that they give me, and then just a matter of solving it. Let's go ahead and take our calculators for a moment, and let's go to this point right here. Okay. So I want you to put in your calculator, go to your y equals, and put x plus 4, and x minus 1. And then we want it to equal 12, so let's put 12 in our y cube. Yep. Right. So if we graph this, we can see there's 3 different answers there, 3 different values there. We're across the x-axis, which we would figure across the x-axis 0, -4, and 1, right? But that doesn't tell me the answers, because I want to know when it equals 12. Right? Can you see that straight line where it equals 12? There should be a horizontal line there where it equals 12. You might see it? Okay. So we need to change our window so that our y max is at least 12, so I'm going to change it to 15. So that then I can see that line. So our answers we got with -3, -2, and 2, we can see all 3 of them on our graph here. But obviously, like Emily said, that only the positive one works. So here I've used my graph, and I could even go to my table to see that at at 2 it's 12. So once I write the main equation I need, even without going through and doing all the multiplication like that, you can do that. But you could also find your answer by using your calculator too. And I could go back here and with my graph, I could find the intersection point. So second trace, and then number 5. And my first curve is that one. Second curve is a line. Okay. And we want only the one that's positive because the negative ones don't work in this case, and we can see that it's 212 there also. And that's finding the intersection point by going second trace. So calculate number 5. You select the 2 curves that you're working with, and then just hit enter. Enter at the guess point, or if there's more than one, then you need to get closer to the one you're really trying to find. But either way, we found out that with a width of 2 inches, the volume of this box be equal to 12, because then it would have, my dimensions would be 2 here, 6, and 1, and 2 times 6 times 1 is 12. Okay. All right. Okay, our last example, this is a little bit tougher to do. We're going to end up using a lot of things that we know, and we're trying to find all of the real roots of a polynomial. So we're going to be using our calculator. We may end up using synthetic division. Okay. So we're going to be given a polynomial function or equation, usually greater than 2, that we will graph it to find our integer zeros first. And then, if necessary, we'll use synthetic division to reduce the function to a quadratic to find other zeros. So let's just take this one and let's graph it, first of all, on your calculator so you can find the zeros. So we have a cubic function. So we would anticipate that we're going to find 3 zeros. Now, that's not always the case. There might be fewer than that. Okay? But right now, we're looking for real zeros, and it shows us 3 of them there. Now, I can't really tell what any of them are. Can you? Zoom 6. Get you back to that nice screen. Right? So let's go to our table, see if we can find any integer zeros here. Anybody find any integer zeros? There isn't any, right? Okay. So maybe we can guess and find some. Let's try a little bit of, let's zoom in here. Let's go to zoom 4 for a second. Let's go to a smaller window. Okay. So it looks like those two around the y-axis might be around 0.5, right? Okay. So let's try, if you hit trace, and if we hit negative 0.5, right? Well, that's at negative a half, so that's not one there. Let's try positive 0.5. I just put 0.5 in there. All right, we have a 0 there, so we can work with 1/2. Right, it's not an integer, but it's a rational number that we can work with. But the other two, like this one here, looks like it's, let's see, 1, 2, 3, 4, about 4.5, right? So let's try 4.5. Okay, 4.5 is at 2. So those other two aren't going to be as easy to find. But we know we have one. We have one of our answers we're looking for is at positive 0.5. So we can use that positive 0.5 with synthetic division to reduce this cubic function to a quadratic, because we know 1 0, so there's 2 left, right? Since there's 2 left, that means it would be a quadratic. I can reduce it to a quadratic where, if necessary, if I can't factor, I can use the quadratic formula to find the other two zeros. All right, so we're going to use syntagmatic division with 0.5 here, because that's our zero. Make sure you put a 0 in because there's no x term. All right, bring down the 2. 2 times 0.5 is 1. Negative 9 plus 1 is negative 8. Half of negative 8 is 4. Or negative 4. Combine them, we get negative 4. Half of negative 4 is negative 2. So 0, which we knew it was going to be 0 because we're across the x-axis. Right? So now we have a quadratic here. This is 2x squared minus 8x plus 4, right? From our doing our long division or our syntagmatic division. Okay. And minus 4. So we're going to use this and do the quadratic formula to be able to find the other two zeros, unless you can factor it. Well, let's see if we can factor it first. I don't think we can, but let's try. All right, take the 2 out first. Are there factors of 2 that when I combine them I get negative 4? It's kind of rough because the factors of 2 are 2 and 1, right? So the best I can do would be 3 or negative 3. Right? So I'm going to have to use the quadratic formula. So if you don't remember the quadratic formula, it looks like this. There's the quadratic formula. When I write it, I always write it in 2 separate parts. So when I do it myself, this is the way that you see it in the book most of the time when you guys did it before. And usually, though, when I write it, I'll write it as 2 separate parts. I find it easier to simplify when it's written that way instead of as just one thing. So we can do it from either we can either do it here, or we can just do it with these numbers here, which my suggestion is to you, if you can ever factor out a number, I would get rid of it, because then you don't have to simplify further when you do the quadratic formula. All right, so in this case, A is 1, B is negative 4, C is negative 2. Make sure you identify what A, B, and C are so that you put them in the right spots. Because this quadratic formula tells me when ax squared plus bx plus c equals 0. And we start plugging in the numbers. Now there's good things about both parts of either way of writing the quadratic formula. One is sometimes the people that write it the way I do, they tend to think that everything is under the radical, but that fraction bar divides the radical. The radical's in the numerator, the other part's in the denominator. So make sure you don't mistake that. So here I get 4 over 2 plus or minus the square root of, and that's 16 plus 8, right? So 24. So we have 2 plus or minus. And how many of you remember how to simplify radicals? Okay, Rachel does. Yep. Look at that. There's that quadratic formula. Yep. So we're going to go, it is, we take the square root of 24, and we want to find the largest square that goes into 24. Okay, well, we have our squares right here, right on the board. Okay, what's the largest one of these numbers that goes into 24? Okay, 4 does, right? 16 doesn't go in evenly, so 4. So this would be the square root of 4 times the square root of 6. And the square root of 4 is 2. So it would be 2 square roots of 6 over 2. And these 2's will cancel. So we have 2 plus or minus the square root of 6. So my answer for this problem is 0.5 and 2 plus or minus the square root of 6. Those give me exact value answers. How about we do another one then? Okay, so first thing we'll do is if you can't factor it, okay, if we can't factor it, then we're going to graph it, hopefully find integers that we can use for the zeros. If we find enough of them that where we can then use synthetic division to get it down to a quadratic, we want to do that, because then we can always use the quadratic formula to find the last two. All right. So let's, all right, let's do this number 12 here. All right, so they want us to find all the real roots. So let's graph it. Now, well, let's hold on. Let's look and see if we can factor this first of all. Because we got, it's possible that I could factor this by, okay, by grouping. So we've got, let's see, 3x squared times x minus 6, right? All right, but does 9 go into 132 6 times? I don't think so. No, because 9 times 6 is 54, isn't it? Okay, so these won't be the same. All right, so I can't do grouping. We'll get rid of that. All right, so let's graph it. to go back to Zoom 6 then, your standard viewing window. Let's see, between -2 and 3, and then it looks like there's 1 at 4, doesn't there? All right, so I've hit trace and 4, see if there's 1 there. Yes, there is. Or I could go to my table, and I can see that there's a 0 at 4. So we have 1 0 at 4, and we need to find the other 2. Now, one other thing was, when I look at this, it looks like everything might be divisible by 3, right? Is that true? Does 3 go into 132? Three. 44 times? Okay. So I could simplify this to x cubed minus 6x squared minus 3x plus 44. Those numbers will be much easier to use, right? Okay. It's an equation. So what did I do? I divided both sides by 3. That'll give me smaller numbers. Okay. So we know that the only integer 0, or 0 that I can really use, is at 4. So then I'm going to use this 0 at 4 to reduce this cubic polynomial to a quadratic, to where then I can do synthetic division, or to where I can use the quadratic formula then. All right, so we're going to use the 4 and do synthetic division. So the nice thing about doing the quadratic or synthetic division is when I'm done, here's my values for A, B, and C for the quadratic formula. And I know I can't factor that because the factors of -11 are 11 and 1, and they don't add up to 2. So I'd have to use the quadratic formula then. All right, so let's try that one again. So we have -2, or I should say the negative of -2 over 2 times 1, plus or minus the square root of -2 squared, b squared minus 4 times a times c, divided by 2 times a. All right, if you need to see it again. There's that quadratic formula again. Okay, so under the radical, you should have 48 in this case. All right, and so we have our list of squares over here on our board, and what's the largest one of them that goes into 48? Let's see. Does 16 go into 48? Okay, 3 times. All right. So we have 1 plus or minus, and the square root of 16 is, okay, so we have 4 square roots of 3 over 2. So that would simplify to 1 plus or minus 2 square roots of 3. Now this is where I like to pull it apart, because when it's pulled apart, you can actually simplify this easier, because if it's just one long fraction, then it's not as easy to see the simplification that can happen, because you end up in this situation here. It would look like this. It would be 2 plus 4 square root of 3 over 2. And what happens in that case is that people might cancel the 2's, okay, simplify the 2's, but not the 4 and the 2. So, it just kind of depends on what you like, which way you prefer it. Like I said, I prefer it pulled apart. Some people like them together. So either way, you're still going to end up with the same result. So our answer is 4 and 1 plus or minus 2 square roots of 3. And we can actually verify them on our calculator. If we go back to our graph, and if we hit trace, type in 1 plus 1 plus 2 square roots of 3, we get 0. Or if we do 1 minus 2 square roots of 3, we get 0. Okay. So you can verify that those answers you got are correct by just going back to your calculator and checking the graph for those numbers by hitting trace and then typing them in.